All right, how are you doing? All right, here we go, people. Um, the idea is that you should be able to sketch these. Please don't think low square root, they're square root graphy in nature. They're not, they're conic sections. Your method should be something like square both sides and get it more into a standard form. So that, for example, tells me that is a circle, but because it was only the positive root variety, it's not the full circle, it's only the top half of the circle with a radius of 2. Tell me, how can I use domain to confirm that graph? I know the domain involving a root means I can't square root a negative. So would you agree that x cannot be too big or I'm going to get a negative? And so it's logical that x stops at 2 on the positive side and negative 2 on the negative side? Wait.
Yes.
So use domain. Okay. The next one. If I square both sides, I get y squared equals x squared minus 4. Put it in some kind of standard form. You could move either side over, but doggone it, I kind of like that 4 to be positive. So I don't know about you, but I move the 4 over and the y squared back, and I got that. So what is that? Parabola, ellipse, hyperbola, circle, hyperbola. It was still positive y's. So instead of the whole sideways opening hyperbola, it's only the top half. We? Okay, are you with me? All right, tell me, end behavior of this. As x gets infinitely large, this starts to approach just the square root of x squared, or y equal x. And therefore, it starts to approach linear behavior. That end behavior can be used to confirm that asymptote behavior. All right? Last but not least, if you square both sides, y squared is 9 minus 2x squared. Move the 2x squared over. What happens, so what kind of graph is it if I have a sum of two squares, but they're different coefficients? It must be an ellipse. Now, I don't, this one gets kind of gross, but it's okay. I'm smart enough to handle this without a calculator. So when you divide 9 over, 2/9 is fine, but it needs to be everything in the denominator. So 9/2 in the denominator. Oui? Okay, for the x change then, it's the square root of 9/2. What's 9/2? 4.5. So what's the square root of 4.5-ish? 2-ish. Okay, so the horizontal change sideways should be 2 a little more. -2 a little more. And the y change is up 3, down 3. But do I have the whole ellipse or only part? Only part, only the y's that are positive. Okay. What's the domain? X must be between, yeah, the square root of 9/2-ish negative and the square root of 9/2 positive. Just for, thinking purposes, just for the fun of it. All right. Did you have a lovely weekend? Oh, good. Did you have fun? Did you spend time with your parents? You're not going to be here next Labor Day. They're going to miss you. Okay. Labor Day is a family holiday, don't you agree? Okay, all right. I was really lonely when I went to college. Labor Day, it feels like you should be with your friends or your family. But anyway, that's next year. So I have 2 sets of notes to do. You probably have set 24 on you somewhere. It's green, and I never got to it. So if you intend to be a good note taker, I would look for that, find it, and get that out. Believe me, I assure you, as a teacher of junior high students, I do not take for granted that I can give you a paper, that you can hold on to that paper, for a couple days and you will still have it. That to me is a miracle. Junior high students can't seem to all do that. All right. And maybe a few in this class. Howdy, hi, Haley. Thank you. All right. Boom. So, set 24, the car rule for derivatives, also known as greatest shortcut in all of mathematics. Are you ready? He doesn't want the greatest shortcut in all of mathematics. Would you start by, first you got to earn it, all right? I can't just give it to you. That's not my nature. You got to see where it comes. Am I right? So, let's go a little something like this. If I wanted the derivative of x squared by the definition of the derivative, then I might say something like the limit as h goes to 0 of f of x plus h minus f of x over h. That's the first definition of the derivative. On the test, many of you feel like that limit is optional in the definition of derivative. Yeah, no. Without the limit, there is no derivative. Is that understood? Without the limit, you're just taking the slope between 2 points and stopping. There's no derivative there. So that limit is important. Please make sure you write it. And continue to write it. Don't give me the old, yeah, you know, it's always, no, I don't know it's always there. You write it until you take the limit, people. So, f of x plus h, that is the quantity x plus h squared. Oui, oui?
Yes.
Minus f of x, which is x squared over h. What is the expansion of x plus h squared? X squared plus 2xh plus h squared. Most people remember that one. The cube and beyond, we'll see. We'll see. Oops, that's a square. My bad. The x squared subtract away, and x divides away, or h divides away, excuse me. And we get the limit as h goes to 0 of 2x plus h if we divide out an h. Then you take, notice that the limit statement is there the whole time because nowhere in here did I say let h go to 0, let h go to 0. Until I actually put in 0, the limit stays. Now I'm ready to put h in, a 0 in for h, and I get 2x. Okay. Now we're going to look for trends here. It looks like the derivative of x squared is 2x. 2's maybe special? Hello, Miss Witherspoon. We'll see. We'll see. We're going to look for patterns, but let's proceed on. Let's say we did a cube. By the definition of the derivative, I'm going to just go straight to the chase. What is f of x plus h then would be, in this case, x plus h quantity cubed minus f of x, which is x cubed, all over h. Do you remember the expansion of x plus h cubed? Nope. X cubed plus 3x squared h's plus 3x h squared plus h cubed. So many patterns here at work. A square has 3 terms, a cube has 4 terms, and I just lost altogether one. Okay, and the pattern of the exponents, all that good stuff. So if I use that here, then I get something like x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. Really? Alright. X cubes subtract away. Everything left has an h in it, so I can divide an h out. When I divide an h out, what is left? Anybody? 3x squared plus 3xh plus h squared. Now, the last terms have an h in it, so they'll go to 0, leaving me with just the 3x squared. So it seems like, again, looking for patterns, the derivative of x cubed is 3x squared. The derivative of x squared was 2x to the first. What do you reckon the derivative of x to the fourth is? 4x cubed. We'll see. We'll see. What is the expansion of x plus h to the fourth? I'm going to give you a little. X to the fourth plus 4x cubed h. The x's gradually go down in power by 1. So 4x cubed h plus 6. Ooh, I'm impressed. What do I mean? Plus 4xh squared plus h cubed. And x to the fourth expansion has 5 terms. So by the definition of the derivative, the limit as h goes to 0 of my expansion of x plus h to the fourth minus x to the fourth over h amounts to x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth minus x to the fourth over h. Lee? I'm starting to see what always happens. Wouldn't you agree that that first term always seems to subtract away? Yeah? And all the other terms have h's left. The first one only has a single h, so that when you divide by h, the h goes away, and that first uncanceled term is just going to be a Plato x term with no h. Everything following it will have an h or more. And so everything past the second term seems to always have h's in it, and therefore always go to 0, which means when we do the limit, the only thing that's left standing is the second term every time. Now our derivative is 4x cubed. Again, the first term subtracts away, it always goes away. All the other terms tend to h out, and the only term that really is left standing is the second term, because it's the one where it has only a single h that goes away. Now, keep that in mind as we go to the general. Let's say, instead of doing this for every case, we just develop a general rule for any x to any power, all right? The binomial expansion of x plus h to the n. What's the first term? You know for sure. X to the n. When we go to the second term, every time when it was cubed, it's 3x squared h. When it was fourth degree, it's 4x cubed h. So what about x? What about the second term? N, x to the n minus 1, and a single h to the first. And then dot, 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 dot. And what does it always end at? H to the n. Okay, now, that's really all we need to develop the derivative. The limit as h goes to 0 of any x plus h to the n minus x to the n over h. The ones that I really care about are the first one. I know the first one is going to be x to the n, and it'll subtract away. And I definitely care about the second one. That's the star of the show. The second one being, as we just said, n, x to the n minus 1, h. And a whole lot of other stuff ending in h to the n, and then you subtract an x to the n away, right? Now, each time, what happened? The first one subtracts away. And the second one loses its h, because it only has one. So it is just left with nx to the n minus 1, and all that's left is a bunch of h terms. So when you take h to 0, all those h terms drop out, and all that's left is nx to the n minus 1. Now that is the power rule. When you take the derivative of any x to any power, you just bring the exponent down in front and reduce the exponent by 1. So if I have f of x is x to the 7th, then without the definition of the derivative, I'm just going to use the shortcut. I bring the exponent down. So 7 comes out front, and reduce the exponent by 1, it becomes 6. The derivative of x to the 7th is 7x to the 6th. Sometimes it's not all pretty princess for you. You have to do a rewrite step. For example, the square root of x is a power. It's x to what power? 1/2 power. If you can write it as an exponent, then you can use the power rule. So what's the derivative? 1/2 x to the negative 1/2. Say you were doing a multiple choice test and that wasn't there. What's another way it might be written? 1/2 root x. The negative exponent means denominator. The half obviously means root. Cool. Okay? Again, a rewrite step in some cases. Rewrite it as x to the what power? 1/3 or negative 1/3? Negative 1/3. It's in the denominator, which means it's negative. The root is the same as the 1/3 power. Now we can use our power rule. What is the derivative there? Negative 1/3 x to the negative 2/3. Okay, you might also see that as negative 1/3 cube roots of x squared. Negative 2/3, you said negative 2/3. You meant, I said negative 2/3, but you said 4/3, sorry. Yes, negative 1/3 minus 1 is negative 4/3, so this should actually be 2/3. Okay, thank you, you're right. Okay, all those, by the way, they asked for the derivative of x, of x, of x. If they wanted the derivative specifically at a number, we could then write the number in. Let's do one case like that. Say I had h of x is x to the 8th, and I wanted h prime at 1. This goes to my preference here, okay? If you are asked to find a derivative at a certain number, I first want you to find the actual derivative generally, which is 8x to the 7th. Draw this bar here and say, I'm going to evaluate that at x equal 1, and therefore that slope at that point is 8, okay? I'm trying to prepare you both for good math and the AP test. It is often the case that they have this broken into 2 points. First finds the general derivative, then evaluates at 1. If you just go straight to 8, you will only be getting half of the points. All right? So, would you try no? Are there any at the bottom of that page? All right, easy enough. Never mind. Let's go to the other. Step 25. Now we have all these great shortcuts. Then we need to expand out a little bit. Sometimes you're going to have a coefficient with that x to the 5th, like 7x to the 5th, or 8x to the 3rd, or something like that. Okay? If, oh man, I'm rough. I'm making you use the rule. Would you, we kind of already did this, yeah? All right. So I'm not going to make you use the definition for that guy. What is the derivative of x cubed by power rule? 3x squared. Okay. I'll let you do that. But now, g of x. G of x is slightly different in that there's a 2 out front, and the hope is that we can not just take a guess, I think you do this, but actually see what should happen. So I want you to use the definition of the derivative to find g prime so that we can ask or answer what happens if I have a coefficient. Use the definition of the derivative to find the derivative of 2x cubed. How we coming? What'd you get? 6x squared because you were able to get there by the definition of derivative, or just because you knew the rule? All right, well then, the idea is that you see what happens here. If x cubed's derivative is 3x squared, and 2x cubed's derivative is 6x squared, then what seems to happen if you have a 2 up front, or a coefficient up front? And you just kind of stash it out there and multiply it later, okay? So if you have a coefficient up front, leave it out front. Take the derivative of the variable part, and then multiply later. All mentally, you don't have to show all that work. Okay? So, is there practice after that or no? No? What the heck? Okay, so what is the derivative? If h of x is 7x squared, then h prime of x is 14x to the first, right? We bring the 2 down, drop the exponent by 1, and multiply that 2 and 1 together. What if I have k of x is 2 root x? Then k prime is what? Come on. What would be, what's the coefficient? 2 times a half, so altogether those wash and you get 1, and the x drops by an exponent 2x to the negative 1 half. Okay, so if you have a constant out front, just take the derivative normally on the variable and multiply the constant times your derivative. Okay, maybe not. All right, next idea. What happens if you get a sum? You have 2 rates of change. For example, let's say Tegan here does 2 problems per hour. This house does 5 problems per hour. Together, the rates of change are 10 plus 5. Good job. 7 plus 5. So the idea is you can take their separate rates and add them. If you have a function of 2 pieces, like you have 2 terms, like x squared plus x cubed, can you just take the derivative of the sum? And the answer is, I don't know yet. I'm making you do the definition of the derivative. Golly, that's mean of me. Get over it. H prime is, so I'm telling you h is a combination of 2 functions kind of dealio, yeah? By definition of the derivative, the limit as h goes to, h goes to 0. That's unfortunate. I use h in the definition of the derivative, but here they call the function h. So I can't use h in my definition of the derivative. What else could I do? Bless you. All right, well, some books call it, instead of h, they call it delta x. So we're going to use the same definition of derivative, but we can't use h in our definition of derivative because they are using h to name the function. So h of x plus delta x minus h of x all over what? H or delta x? Delta x. Okay. Now, they say that h is a combination of f and g. So if I put x plus delta x into h, then I really have to put x plus delta x into both f and g. So this would then be the limit as delta x goes to 0 of, instead of h of x plus delta, I have f of x plus delta minus, or plus, g of x plus delta, and that whole thing is the same as h of x plus delta. Now I need to put h in parentheses or brackets, and that is just normal old f and normal old g. We? And here's where, unfortunately, our book teaches things weird in that they do limit rules much further down the line in like set 71, which you are nowhere close to. But you're just going to have to take my word for it. First, understand that you can distribute. No problemo. Distributing the negative. Wait. Second, limit rules allow you to basically use the commutative property of addition. I could write f terms together and g terms together. That's allowed. You follow? Second, rules of functions. Say I had a sum like that. Is it mathematically allowed to break it up and put each of those separately over the denominator? Are those the same? Is that allowed? Yeah, that's allowed. That's undoing it, adding fractions. In this case, then I'm going to split up the f. Oh, how embarrassing. Free donut for you. But not really, I guess I'm not supposed to give you sweet food or something like that. I'll just give you a sorry. All right, so I'm splitting that into 2. My idea being that I want to get 2 definitions of the derivative of each individual guy. Last but not least, if can I split those into 2 separate limits? Is this true? If I take the limit as x goes to 2 of x squared plus 4x, can I do that just by saying what does this guy do at 2 and what does this guy do at 2 separately? Can I just say what does 2 do to each one of those separately? Is that allowed? It is allowed. So, in essence, we're saying this is the same as the separate limits of each of those individually. Should have made you do this on your own. Okay. What does this represent? This guy here is the same as the derivative of f plus, what does this guy represent? Derivative of g. So if you get a function that is a sum of 2 different functions, you can take their derivatives separately. Yours is right. So the sum rule is that if you take the derivative of a sum of 2 functions, it's the same as each separate derivative. Now don't get cooped up by this notation. It's just Leibniz notation of the derivative. This just means the derivative with respect to x of f and g is just f prime plus g prime. You can take the derivative of each separately. Do I have practice yet or not yet? Here, h of x is x to the 7th plus 2x cubed. What's h prime? 7x to the 6th, derivative of the first, plus 6x squared, derivative of the second. Let's take each derivative separately. You're using the coefficient rule in there. Are you with me? Okay. All right, last but not least, derivative of a constant. Would you please, on your own or with your math amigos, show graphically why the derivative, if you're given a constant function, f of x is some constant, show graphically why the derivative of that function would have to be 0. Then use the definition of the derivative to show why it's supposed to be there. Now this is where you need to get practice, because this is something I do expect you to be able to do. Prove something using the definition of the derivative. Just find us the copy of me. Put together, talk it over. Do not just sit there and say, I don't get it, wait for him to do it, that makes me mad. Okay, so what does the graph of f of x equals a constant look like? Horizontal line, yes. Horizontal line, somewhere, wherever C is, okay? Great. How does that help me picture the derivative? Well, derivative graphically means the slope of the tangent. If I draw a tangent to any point here, it's always 0, so the tangent slope is always 0. That makes sense then, that the derivative of a constant function would be 0. Let's show it analytically, let's prove it. So starting from the definition of the derivative, if I put x plus h into a constant function, what do I get? Okay. F of x equals 3. What's f of x plus h? Not a trick question. Okay, what's f of x plus h? 3. What's f of 2? 3. What's f of 8? 3. F of 20? 3. F is always 3. What's f of my mom? 3. Exactly, okay? No matter what you put in, it doesn't matter. You get out of 3, period, always. So, what is f of x plus h? 3. Okay, what is f of x? 3. Hey, look at that. The top is 0. The change in y is 0. Oh, yeah, that makes sense. It's a horizontal line over h. So, what do I get? I get 0 over h, and that is 0. Oops, and as h goes to 0. Is 0. Okay, 0 divided by any number, 100, 1/10. Remember, we're not saying h is 0. We're saying as h gets closer to 0. So 0 divided by 20, 8, is 0. 0 divided by 10, 0. 0 divided by 100, 0. It's 0 is not 0 over 0. All right, you with me? Okay, so then, if you could do these, is there 6? Is that right, or is there more? Okay, do these. There's 11? Do I have more? Okay, do these bad boys, and I'm going to find the other ones. Feel free to check with your math amigos. And I'm gonna find where I put my extras. I like 8. I made more. Okay, every time to play around with these. If you need help, let me know. Or ask somebody around you. Oops, that's 4, not 1. Boy, I started you off with such a hard one. What's the rule? Put down the exponent and subtract by 1. So bring down the exponent. Subtract by 1. So root 17 minus 1. That's it. Sorry, I started you off with the hard one. I shouldn't have. I feel bad. Now it'll be easier.
positives, so it's 1/3, yeah. So the x is the negative, so it's just negative 1, right? Yeah. So it's -2, but you minus 1 here, so it's -2, so I just put x squared. Yeah. Wait, what's x squared minus 1? Hold on. Wait, hold on. Hold on. That's what I do for half. It's that. 4x squared. What 4x squared is? Oh. No, there's not. Yes, you put it there. No, I just. It's just -2. It's -2. Oh, is it for 4/3 x to the 1/3? Can we go back to that part? It's 4/3, yes. X to the 1/3. X to the 1/3, yeah. Okay. How do you negative 8 squared? 64 years. I know, I'm not driving right now. So it's negative, it's actually negative times 1 to the x plus x to the 1/3. Is it to the 1/3? So it's negative 1/36. I can't understand what you're saying. Wow. X to the 1/3 is. Okay, so you can put an 8 for x. I get that, but it's 2. No, so this isn't. I don't understand. Because 8 of it is you idiot. Oh, okay. Okay. How do you do it? Oh, do you do the same thing? Yeah. So you term by term, and then you put in 1 after you take the derivative. Wait, what is x thirds to the 1? So, that is the same thing as x under 3 plus 0? Is it plus 0? Yes.
All right, are we ready to hit those? No, not yet. Okay, cool.
Wait, yeah, actually.
Yes?
Never mind.
Okay. So, sorry about the first one being too rough. That was dumb. What's the derivative of a constant? 0. So does it matter that they said, well, what about a 3? Does 3 matter? No, it's still 0. Okay, it doesn't matter if it's a 3 or 2 or 10 or whatever. The rate of change is still 0 because a constant doesn't change. It doesn't have a rate of change. A constant doesn't change. It's a constant. It's in the name. What about the derivative of x cubed? Or sorry, yes, x cubed. 3x squared, derivative of x squared. 2x and the derivative of constant -1, 0. So there's your derivative there. Okay, 3. Number 4, it helps to do a rewrite step. So you have powers, then take the derivative, something like 1/2 x to the -1/2 plus 10x plus 0, or just constant derivative of 0, right? Okay. What about this? If I rewrite, it's 2x to the -1 plus x to the 4/3. Now that they're powers, we can take their derivatives. The derivative of the first is -2x to the negative second plus 4/3 x to the 1/3. If they then wanted it at 8, I'd have something like -2. What is 8 to the negative second? 1/64 or over 64 plus 4/3. And what is 8 to the 1/3? It is 2. It's the same as the cube root and 2. So we could put that together if we were so inclined and get a common denominator. Okay. 6. H prime here. What about, now here, I'm trying to get across that I want you to do derivatives. If they ask you for derivative at a number, I want you to do in 2 steps. First of all, find the derivative at any old x, then find the derivative at 1. You can do notation a couple different ways, but I should see the x derivative, then one going in 2 steps, understood? What is the general derivative of 2 over x, or 2x to the negative 1? Negative 2x to the negative 2. What's the derivative of x to the 3 halves? 3 halves x to the 1 half. And what's the derivative of 7? Nothing. Okay, so h prime at 1 is negative 2 over 1 to the negative 2, which is just 1, plus 3 halves times 1 to the half, which is just 3 halves. So did you get something like negative 2 plus 3 halves, or maybe negative 1 half?
Good morning, Devlin Jetline.
Sure. Time goes fast.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'll put these up while you're chilling.
Don't forget the directory cover art contest. Pick up a submission form from the main office. Your form and artwork are due by this Friday at 7:30 a.m. to the office. The winner will receive $50 in addition to having their artwork on the cover of this year's directory.
Don't forget to wear your favorite colors.
Tomorrow at lunch, 14 amazing Colorado colleges will be here in the large gym to meet all of you. Get started on your college journey. There will be candy and prizes such as t-shirts, water bottles, socks, college bags, drawstring bags, and much more.
Folks know that there's superior access to back to court. There will be counseling today from 7 hours. So that's getting knocked out.
There will be a robotics club meeting 7th hour in the computer lab at H202 Friday, September 7th.
All cats.
That one they do say point, so x and y.
Even if you don't have it. Thank you.
Yes.
The first girls' mentoring meeting will be this Friday, September 7th in classroom.
Yes.
We will post your assignments and mentee or mentor pairs on the bulletin outside the cafeteria on Thursday.
Hi. Okay, thank you.
Attention seniors, don't forget your senior yearbook forms are due to Mr. Jacobs in the library by September 7th. Additionally, please send your senior photos to the link on the school website by September 7th. If you don't turn these in, you will be in your yearbook. Eighth grade members of junior high student council will be studying history for those hours. Sign up with your U.S. history teacher that comes this week. This meeting is only for the 8th grade members. The boys golf team had another strong showing at the last Jeffco League meeting. Our match today, Fort by Stroke. Inspires leads the way with the tournament at 75, followed by Ned Strumstra at 80 and Villafon at 81. Tyler Carver also participated in helping the team maintain their third overall league standing position. Congratulations to all the golfers.
Okay. These were probably a little tough at the end. I'm not sure if you're able to get started, but we will gradually build up to it. The point is there are a lot of ways to use the derivative, or a lot of different questions that could be asked. This would be 0 if x to the 3 halves minus 1 is 0, which is only at x equal 1. And I didn't find the y. So, question then, what do we do about 23, 24? We don't have time for questions. Should we just turn it in tomorrow?
Yes. Yes.
This is the last time I'll have 2 sets to teach, probably, hopefully, so I guess that'll be okay. All right, so I'll take, tomorrow you will be turning in both 23, 24, and 25. So, make sure you have those 2 for me tomorrow. Okay, I do have the tests in, by the way. You need to understand that the test is curved heavily. And so if you got the C on it, that's probably not good. Okay. I curved this a lot. A lot.